Good afternoon, my YouTube viewers. It's Crystal here. I'm just here because I wanted to make another code review on Kaggle's Playground Competition, Series 3, Episode 13. And this is classification with a tabular vector-borne disease dataset. And so a vector-borne disease is a disease that you get from something that draws blood, because I wasn't sure what it was, and I looked it up. So it's like a mosquito or a tick or something like that. And that's what a vector-borne machine is, just in case you didn't know what it was, because I certainly didn't know. So I made this program on Kaggle's Jupyter notebook, and it is stashed in the directory that the competition question is stashed in. And I only got a public score of 21%. I tried to use it with a deep learning network, and then I was reading on the internet that deep neural networks aren't very good with tabular data. So I decided I'd try it with a gradient boosted trees, and I got an even lower accuracy with gradient boosted trees than I did a deep neural network. So everything is subjective. You read a lot of stuff on the internet, and some of it isn't correct. So in this instance, gradient boosted trees did not perform as well as a deep neural network. So we'll go ahead and read the problem statement for this competition question, which is the data set for this competition, both train and test, was generated from a deep learning model trained on the vector-borne disease prediction dataset. Feature distributions are close to, but not exactly the same as the original. Feel free to use the original dataset as part of this competition, both to explore the differences as well as to see whether incorporating the original in training improves model performance. Note that in the original dataset, some prognosis contains spaces, but in the competition dataset, spaces have been replaced with underscores to work with the MPAK metric. So that's our problem dataset. And basically what we're doing is we're predicting on these vector-borne diseases, something like malaria, because you can get malaria from getting bitten by a mosquito, and then you can get Lyme disease, I think, from being bitten by a tick or something, but I don't know a lot about vector-borne diseases. I looked it up just today because I wasn't sure. So the first thing we're going to do is import libraries. So we're going to import NumPy as NP. We're going to import pandas as PD. We're going to import OS, which we didn't actually use OS in this problem. I'll explain that in a little bit. We're going to import matplotlib.pyplot as PLT, and we're going to import Seaborn as SNS, and we're also going to import the Tensorflow libraries later on in the program. So basically, I didn't really use the OS because I accidentally deleted the piece of code where it says you go into the directory and get the files. But what I did was in the actual, if you're on Kaggle and you're editing a notebook, on the right hand side they give you the input files. So I went into the input files and got the input files. So I didn't really need OS anyway. I tend to use it, but I didn't need to use it. So I just read the files by going into the right hand side of the notebook when you're in the edit mode, and I retrieved the 3 files that we were going to use in this program, being train, test, and submission, using pandas read CSV function. So we look at train, and you can see we've got 66 columns, the last column being prognosis. A lot of these columns are going to be yes, no. So that's what I've noticed. Headache, yes, no. Mouth bleed, yes, no. So if it's a 1, it's a yes. And if it's a 0, it's a no. We check the info on the train. You see they're all floats, except for the last one, which is a prognosis, and that's an object. Then we do a describe on a train. So if you want to see a description for all of the columns, then you can get that. And now that I think about it, I forgot to take out the ID, and that's one thing that I can do, is I can drop the ID because we don't need the ID, and that could possibly improve my score. Then we check for null values. We don't have any null values. Then we check the test, and you see we've got the ID again. I didn't even think to drop the ID, so that's one thing that I will do, is drop the ID. Look for null values. We don't have any null values. This is what the submission looks like. That's what they want to see. I'm going to analyze train. So we did a disk plot on the prognosis, and you can see I think that there are 11 prognoses that you can get. And then so what we did was we did a value count, and so you can see how many times each vector-borne illness occurred in the train data frame. We check the class, that's the number of classes in the prognosis, and that's 11. And now what we're going to do is we're going to use sklearn import preprocessing, and so we're going to encode the label, because in order for the model to work, it has to be converted to a number. So that's what we're doing. We're converting the 11 classes to numbers. I did a heat map, and so you can see the heat map, and you can see in the heat map that none of the features are very highly correlated. Look at the correlation. If you want to see the correlation, you can see the correlation, and if it's a positive, then you can see it's highly correlated. So our correlation goes anywhere from -0.2 to 1. So you can check your correlation there. But what I did was I put in some code to identify the columns that were highly correlated, that were correlated above 95%, and there were not any columns that were correlated above 95%, so I didn't need to remove any columns. So now we're going to split the data set into training and validation sets. So train df equals train.sample, frac equals 0.9, random state equals 0, val df equals train.drop, train df index. So you can check your shape of your train df and your val df. So now we're going to separate features from labels. So we're going to make a copy. Train features equals train df.copy. Val features equals val df.copy. Train labels equals train features.pop. Prognosis. So your train labels is your prognosis. And val labels equals val features.pop prognosis. So that means val labels is your prognosis. So you can see your val features and your val labels, and your train features and your train labels. So we're going to check the number of features. So equals train features shape 1. So that's 65. We're going into TensorFlow. So we're going to import our TensorFlow libraries and their associations. We're using version 2.11 in TensorFlow. And now what we're going to do is we're going to normalize the data. Normalizer equals tf.keras.layers. Normalization axis equals -1. Normalizer dot adapt NP array train features, and then we print normalizer mean numpy. So what we're going to do is we're going to normalize the first row of the data frame. And so you can see when we normalize the first row of the data frame, you can see what it is when it's not normalized, and you can see what it is when it is normalized. Now we're going to go into a deep neural network, and I worked on that a lot this morning on the deep neural network because I originally had dropout in there, but dropout did not improve the accuracy. If anything, it made the accuracy a little worse, so I took the dropout out of it, but we kept the normalizer in. So model equals keras.sequential, then you've got normalizer as your first row, keras.layers.flatten, input shape equals num feature, comma. The next row is keras.layers.dense 128, activation equals tf.nn.reloop. The next layer is keras.layers.dense 256, activation equals tf.nn reloop. The next layer is keras.layers.256, activation equals tf.nn.reloop. And the last one is keras.layers.dense num class, that's 11, activation equals tf.nn.softmax. So in theory, I guess I could take out one of those layers and see if that improves it. The next thing that we're going to do is we're going to compile the model. The optimizer is going to be atom. Loss is going to be sparse, categorical, cross entropy, and metrics is going to be accuracy. And then we're going to fit the model which trains it. So model.fit, train features, train labels, epochs equals 2000, batch size equals 1028, verbose equals 0. And then val loss, val accuracy equals model, evaluate, val features, val labels. And it's going to be print val accuracy. So we had an accuracy of 30%. Now we're going to make predictions. So predictions equals np.argmax model.predict test axis equals -1 predictions. And then now what we have to do is we have to reverse what we had originally done early on in the model. So predictions equals le.inverse transform predictions, and then we're going to flatten it, and then we're going to print out the predictions, and so you can see that the predictions are printed out now that it's been flattened. And so now what we're going to do is we're going to prepare our submission. So submission prognosis equals predictions, submission to CSV equals submission.csv, index equals false, submission equals pd.read CSV, submission CSV, submission. So this is the submission, and this is the score that we got. Was 21%, which wasn't very good, but hey, I did my best. And when I finish this code review, I'm going to go through and I'm going to delete the ID column from the train set and the test set because you don't need the ID column. The reason why you don't need the ID column is because all of the rows are indexed anyway. So the ID column is just redundant information. So, I'm going to go ahead and complete this code review because I've covered everything that I want to cover, except for the fact that I tried this on gradient boosted trees, and which and I didn't get as good an accuracy. So I was reading on the internet that tabular data is not good on neural networks. And so I thought, okay, well, I'll try random forest or gradient boosted trees. So I gave it a try, and the accuracy was actually less. So in this case, a deep neural network outperformed gradient boosted trees. So now that I've said that, I'm going to go ahead and conclude this code review. I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a new video, please tap onto the bell button beside the subscribe button. And thank you so much for watching my code review. I look forward to making more code reviews for you in the future.